Fishery products are a healthy and valuable protein source, accounting for about 17% animal protein consumption globally. This ratio exceeds 50% in some areas in Asia and Africa. China has the world's largest seafood market and produces the most seafood through aquaculture. About 80% of fishery production depends on pellet feeding, which represents about 60 to 80% of the total aquaculture production cost. Traditional fish feeding management largely depends on farmers' experiences and results in feed wastage or sometimes underfeeding, high labor and feed cost, increased water pollution, and decline of animal health and welfare, which imposes severe challenges for the sustainable development of high-quality and high-yielding aquaculture systems. With the rapid development of aquaculture, an intelligent precision feeding strategy provides a possible solution to these problems experienced in intensive aquaculture. Supported by the National Key Research and Development Program of China and National Technology System for Conventional Freshwater Fish Industry, researchers from Huazhong Agricultural University and Wuhan University have developed a multi-factor feeding system to achieve precision and intelligence of the feeding operation, allowing smart control and centralized management of cultured ponds or tanks based on fish biology, artificial intelligence, cloud computing, the Internet of Things, and fishery machinery. This precision feeding system has been developed for active feeding fish species such as largemouth bass, grass carp, yellow catfish, gibel carp, blunt snout bream, silver sea perch, and Japanese sea bass, etc. The feeding system mainly includes a bioenergetic-based nutritional model, real-time water quality monitoring system, fish feeding activity sensor, automatic feeding machine, and cloud server to realize remote farm-to-farm intelligent precision feeding. The feeding system has been successfully developed and deployed in multiple scenarios supported by fish biological requirements, cloud data storage, intelligent computing, and auto feeder control, allowing fishery practitioners to better understand the full cycle of production simply with a mobile device. There are 3 function units required to determine the precise feed requirements of fish, which is the core technology in this system. The first unit involves basic prediction of growth performance, feed requirement, and waste output through nutritional modeling based on big data collected from historical archives from different fish farms and published references. The second unit adjusts the predicted modeling feed requirement using real-time dissolved oxygen and temperature measurements collected using a water quality monitoring system. The third unit then precisely adjusts the feed requirement with input of fish feeding intensity obtained from sensors that record fish feeding activity. A cloud server automatically analyzes the acquired information and adjusts the real-time feed requirement according to the culture background, water quality, and fish feeding intensity by controlling the feeding machines. In addition to fish feeding, this system can also predict fish growth and pollutants of nitrogen and phosphorus output from feeding, which makes it a useful tool for product harvest management and tracking waste output. This intelligent precision feeding system is protected by independent intellectual property rights and is widely applicable to different cultural systems such as traditional ponds, pond recirculation systems, land-based recirculation systems, pond net cages, etc. This precision feeding system can be integrated with different feeding machines, for example, pneumatic feeders, centrifugal pond feeders, and screw stirring feeders. This precision feeding system supports diverse aquaculture systems, allowing farmers to precisely manage their stocks and make intelligent decisions to maximize their production and provide high-quality foods to consumers ethically. Successful application of this precision feeding system under different culture modes confirms its effectiveness and highlights its potential to support modern development of aquaculture.